In our today's edition of trigonometry, I'll be teaching you something interesting, and it is called the SOHCAHTOA. Now let's consider a triangle, which is a right angle triangle with 3 sides and 3 angles. Here we have this to be a right angle, angle 90, and we have our theta given here. We have the 3 angles named A, B, and C. Now, where your angle 90 is facing is called the hypotenuse. And where this given angle, the given angle can be here or here, either way. But where theta is facing is called the opposite. And your adjacent is the line that has both angle 90 and the unknown angle theta. So it is called the adjacent. Now, how can we get angle theta given any of these sides? This is going to take us to the use of this formula. Here we have S. S is called sine theta. And it is equal to O. O stands for opposites. Divided by H, which is the same thing as hypotenuse. Secondly, we have C, which is cos theta, equal A, which stands for adjacent, and H, that stands for hypotenuse. In addition, we have the last part, which is TOA. T is the same thing as tan theta, which is equals to O, opposite, A, which is adjacent. This is what we have. Now, if you look at this, in some cases, we have some extreme case, which is, let me proceed by explaining that too. We have something we call cosec theta. In Nigeria, we call it cosec, some call it cosecant, but cosec theta, which is the same thing as 1 over sine theta. It's the reciprocal of sine theta, which is the same thing as, if you find the reciprocal of sine theta, which is going to be hypotenuse over opposite. Also, we have something we call secant theta, which is sec theta. It is the reciprocal of cos theta. And if we find the reciprocal of cos theta, we have hypotenuse over adjacent. And the last one here is what we call the cot theta. For the cot theta, we have this to be the adjacent over the opposite. So these are what we have. These are what we have. Now let's look for an example whereby we want to, okay, for the cot theta, let me just make you understand that it's the same thing as 1 over tan theta, which is the same thing as adjacent over the opposite. So these are what we have. Now let's have an example, and we need to calculate all these ratios. Now, in our example here, we have this example. We have this to be, this side to be 3, okay? And we have this side to be 4. We want to calculate all this. And also, we want to calculate theta. How do we do that? How do we do that? Now, to do this is very easy and straightforward. we want to calculate all these ratios, cos theta, sin theta, tan theta, cosec theta, using this approach. The first thing to do is to get our hypotenuse, because we need hypotenuse to calculate most of these things. Now, how do we get our hypotenuse? Don't forget the Pythagorean theorem I taught you in the previous edition that says that y squared equals to 4 squared plus 3 squared. And my y squared is going to be 4 squared is 16. 3 squared is 9. And my y squared is the same thing as 16 plus 9, which is 25. If we find the square root of both sides, we have y to be square root of 25. And y equals to 5. So here we have y to be 5. The hypotenuse is given. Now let me just write it here. Our hypotenuse is 5. Opposite is 4. And adjacent is 3. So with this information, then we can do everything just in a jiffy. And let's do this. So here we have sin theta to be opposite over hypotenuse. Opposite is 4. Hypotenuse is 3. So sin theta is 4 over 3. My interest is not yet on getting the value of theta, but just teaching you how to get these ratios. Cos theta is adjacent over hypotenuse. My adjacent is 3. My hypotenuse is 5. Tan theta, opposite over adjacent. Opposite is 4. Adjacent is 3. Sorry, this should be 5. Hypotenuse is 5. Now, cosec theta is hypotenuse over opposite. It's just the reciprocal. Hypotenuse is 5, and my opposite is 4. Also, sec theta is hypotenuse over adjacent. Hypotenuse is 5, adjacent is 3. And lastly, we have adjacent over hypotenuse. Adjacent is 3, hypotenuse is, opposite is 4. So now, this is how to answer the questions for any of the trigonometric ratios. In the next video, we are going to proceed to some identities of trigonometry and how we can deal with them. Thank you very much for watching. Please don't forget to subscribe and share this video if you really like it. Thank you very much.